In today's video, we're actually going to take a look at two different lessons, 12.4 and 12.5, that have to do with volumes of prisms and cylinders. The first formula we're going to take a look at is the volume of a rectangular box. Now, you may be familiar with this from grade school, and it's simply the length times the width times the height. What we've talked about in previous sections is that we can calculate the surface area of the base by the width times the height. And if you just think about it, then the volume comes from basically having multiple layers throughout the box in each of the length, and each unit of the length then would be multiplied to show the depth and the volume of it. The next formula is the volume of any prism. And just like we have in a rectangular box, you basically find that area of the base and then multiply it by the height. So let's say we have a triangular prism. By finding that surface area of the base and then doing by the height, you're finding all those multiple cross sections are getting stacked on top of each other to get that depth for the volume. The next formula is that of a cylinder. And you can see the formula for it right here. It's this B symbol times the height. This is just standing for the area of the base of the cylinder. So just like before, you're taking that, and depending on the height of that cylinder, you're stacking those bases to find the volume. Another symbol you might be not familiar with is cross section. It looks like a C with a slash through it, and you'll see this in the upcoming formulas. For the volume of a pyramid, you can see that the formula is 1/3 times the base times the height. Now, that's a little bit different than what we've seen. And if you kind of look at this, it's because if we take a pyramid and we place it inside a cube, it actually takes up 1/3 of the volume. So 1/3 times the base of the pyramid times its height. Then we have a volume of a cone. And very similar to what we just talked about with a pyramid, the 1/3 is because if I have a cylinder and I have a cone drawn inside of it, it's actually 1/3 of that volume of the cylinder. And the last thing we'll talk about before we get to some examples is Theorem 121, which states that the ratio of an area of a cross-section to the area of the base equals the square of the ratio of the figure's respective distances. So this section in here would be considered the cross-section. This down here would be considered the base. From the cross-section to the vertex would be considered K, the distance to the vertex. And then obviously the height is from the vertex to the base. And now for some examples. First example is just a quick one. It says find the volume of a rectangular prism with a base of 20, length of 5, and height of 15. So if we think of our rectangular prism, and the formula for it, let's say that this is the length, this is the height, and this is base. And since it's a prism, it can really be kind of interchanged. So the volume for this would simply be 15 times 5 times 20, which gives you 1,500 units cubed. Our second example asks us to find the volume of the solid below. And what we can see here is it's a semi-cylinder, and it gives you that the diameter is 12, and the height of this, even though it's laying on its side, is 25. So what we want to know is we want to know basically what a area of a cylinder is, and we'll cut it in half. So the area of a cylinder is pi r squared, that's for the base, times 25, which is the height. The radius is going to be 6, so it'll be 36 pi times 25. And again, we're going to divide that in half because it's a semi-cylinder. And what that will give you then is 450 times pi units cubed. Our third example asks us if we have a cylinder glass with height of 6 inches and radius 5 inches. And if it's filled with water, and the water is poured into a rectangular dish with dimensions 4 by 5 by 6, will the water overflow from the dish? Well, you'll basically just need to find the area from both figures. So from the cylinder, or the glass, because the glass is a cylinder, we'll again use a formula we used in the previous example. R squared, which would happen to be 5 squared times pi, times its height, which is 6. So that would give 25 pi times 6, which is approximately 471 units cubed. And we're going to change it to exact units instead of pi because we're comparing it to another dimension. The next one is just a rectangular dish. So this is base times height times length. I'm sorry, this should be volume, that area. And that is simply 4 by 5 by 6, which gives you 120 units. This should be cubed. And if we can compare those, you can obviously that the glass, if poured into the rectangular dish, would definitely overflow. Example number 4 asks us, given the volume of the square pyramid, find the given slant height. Oh, with the given slant height, we want to find the volume. So remember that for the volume of a pyramid, we're going to take 1/3 of the base and then times it by the height. Now, there's a couple of things we need to figure out. We need to figure out what the base is and also what the height is. If I draw a line here, you'll notice that there's a triangle that's 30, 60, 90. And since this is a hypotenuse, that's equal to 2x, meaning that x down here would be equal to 9. And since that's half of going across this pyramid, one of the edges of the base will be 18, and since it's square, both of them will be. Now, since x is 9, the height will be 9 square root of 3. So we'll go ahead and calculate the base by 18 times 18, times it by the height, which is 9 square root of 3. And that gives us 972 times square root of 3 units cubed. And finally, our last example. Example 5. We have a cone and a cylinder below that have the same height and the same base. If the volume of the cylinder is 342 centimeters cubed, find the volume of the cone. Well, just like we talked about when we were talking about the formulas, if I were to put that cone in there, considering it's the same height, the cone is exactly 1/3 of the cylinder. So we multiply it by 1/3 times 342, and that gives us 114 units cubed.